This particular diagram, we had discussed it at the frequency spectrum of AM topic. So now this is nothing but the lower sideband, this is the upper sideband, and this is the carrier component. The amplitude of carrier is Vc and the frequency is Fc. The amplitude of upper sideband and the lower sideband is MA Vc by 2, and the frequency of upper sideband is Fc plus Fm, and the lower sideband has a frequency of Fc minus Fm. So now from this, if you observe students, message signal frequency is nothing but FM, and this particular frequency is present in the upper sideband and in the lower sideband also. Here it is present in the form of Fc minus Fm. But this frequency of FM is totally not seen in the carrier. So that means in AM communication, the carrier will have no information in that. The information whatever we are transmitting is completely present in the upper sideband and in the lower sideband. Now, one more point to be observed here is it is the same information that is present in the lower sideband as well as in the upper sideband. So that means the same information is transmitted 2 times. Okay, so based on this logic, there are different types of how we can transmit a particular AM. Just look at this pop-up diagram here. Here, if you see this, whatever is the upper envelope, the replica of that, the mirror image of that is the lower envelope. Okay, so that is what is represented here as the lower sideband and the upper sideband, which is nothing but the mirror image of one another. Now, let's go back to the power relation that we discussed some time back. One of the discussions we had was that the equation of PT in terms of PC is equal to 1.5 PC or 3 by 2 PC. So if I just rearrange this, I will get it as PC is nothing but equal to 2 by 3rd of PT. Or I can tell that the power in the carrier is nothing but equal to 0.666 into PT. That is roughly, I can tell it as 67% of total power. So what it means is the total power carried by the carrier is equal to 67% of the total power that the AM wave uses. I repeat it again. The power carried by the carrier is nothing but equal to 67% of the total power carried by the AM wave. 67% is nothing but the round off I have given for 66.66%. You can also represent it as 2 by 3rd of PT. So this is that particular carrier component. And if you remember, some time back I told you that the carrier component absolutely has no FM part there. That means it has no modulating signal frequency there. So that means 67% of the power is utilized in transmitting the carrier, which has absolutely no message signal. The message signal is present in the upper sideband and in the lower sideband. Now just observe, if 2/3 power is taken by the carrier, the remaining 1/3 power is taken by the lower sideband and by the upper sideband. So here the power, since the amplitude of the lower and the upper sideband are equal, the power distribution is also equal. Out of 1/3 of the remaining power, half of it, that means 1/6 of the total power, is taken up by the lower sideband, which is nothing but roughly equal to 16.5%, and the other 1/6 of the power is taken up by the upper sideband, again equal to 16.5%. So now just observe students here, I am using 67% of my total power to transmit carrier which has no information, and my information is present in the upper sideband and in the lower sideband, and to transmit that I need 16.5%, but then I am transmitting it 2 times. So another 16.5% is gone here for the lower sideband. Now, from this we can make a wise distribution of power, and accordingly there are three different types of AM communication. The first is double sideband suppressed carrier. Second one, single sideband transmitted carrier. And the last one is single sideband suppressed carrier. I repeat again, DSB-SC stands for double sideband suppressed carrier. SSB-TC stands for single sideband transmitted carrier, and SSB-SC stands for single sideband suppressed carrier. Now what all these short forms indicate is, in case if it is double sideband, that means we are transmitting both the sidebands. In case if it is single sideband, that means either the upper sideband or the lower sideband is transmitted. Talking about this SC, SC stands for suppressed carrier. That means the carrier is not transmitted. It is suppressed. And in case of this one, it is telling it as TC. TC is nothing but transmitted carrier. So that means in this particular case, we are transmitting the carrier. Now, in case of DSP-SC, what happens is, the name suggests double sideband suppressed carrier. So that means here the lower sideband and the upper sideband are transmitted, whereas the carrier is suppressed. By doing this, what we are doing is, we are saving around 67% of the total power that is used. Now, whatever this power is saved, it can be used in strengthening the sidebands so that the signal can travel a farther distance. Coming to the next technique of communication, SSB-TC. In this, what we are doing is, as the name suggests, single sideband. That means either the lower sideband or the upper sideband. Any one of the sideband is transmitted along with the carrier. So that means here we will be utilizing this percentage, that is 16.5% plus 67%, and the saving will be mere 16.5%. In case of DSB-SC, we had 67% saving, whereas in SSB-TC, you see that the percentage power saving is mere 16.5%. In the last technique, that is SSB-SC, here, as the name suggests, single sideband, either the lower sideband or the upper sideband, any one of the sideband is transmitted, and SC here stands for suppressed carrier. So that means we are not transmitting the carrier. So out of the three components, in case of SSB-SC, we will be transmitting either the lower sideband or the upper sideband alone. So that means in this case, we are using 16.5% of the power only, and our power saving is 67% plus 16.5%. So it is roughly around 80 plus. So much of power saving is done. And that is why SSB-SC is one of the most efficient techniques used for communication, wherein there is maximum amount of power saving happening. So this is the detailed description of SSB-SC, SSB-TC and SSB-SC. Moving on to the advantages of SSB-SC. Here about 83.33% of power is saved. The noise interference is much reduced, and the efficiency is very high when compared to the other two techniques of communication. Also, in a given band, more number of stations can be accommodated. Talking about the disadvantages of SSB-SC, they are the generation and reception of these signals are very difficult. They are complicated act. Also, the receiver and the transmitter involved, they are quite very expensive and complex in nature. This is not suited for music transmission. Talking about the applications of SSB-SC, it is used in land and mobile communication, used in telemetry, in military communication, navigation, amateur radios, and in point-to-point speech communication. You can just make a note of these advantages, disadvantages, and applications of SSB-SC, as they can be asked for maybe 1 or 2 marks. Moving on to the next topic. Now we will start with the discussion of AM transmitter. Students, this block diagram is very important from exam point of view. It can be normally asked for 5 marks, wherein 1 mark goes for this block diagram and another 4 marks will be targeted for explanation of each of these blocks. Now, students, observe this block diagram. It is divided into 2 sections. One, we are calling it as the RF section, and the other section, which you can see here at the lower side, it is called as the AF section. AF section is nothing but the audio frequency section, and RF section is nothing but the radio frequency section. These names are given based on the range of frequencies they are dealt with. This block mainly deals with the radio frequency range, whereas this block deals mainly with the audio frequency range. So we will start the discussion from the RF section. In the RF section, the first block is the crystal oscillator block. Oscillator is nothing but a circuit which is capable of generating sine waves on its own, that is, without any input given. Now, about these oscillators, you'll be studying much in detail in the chapter oscillators shortly. Okay, and talking about crystal here, there are some piezoelectric materials or materials which exhibit piezoelectric property, like quartz crystal. You might have heard this. It is used very frequently in most of the watches. So like quartz crystal, there are also other crystals like rockalley salt or tourmaline. But out of all these 3 materials, quartz is the best available piezoelectric material, and because of that, most of the times quartz is used as a crystal. And since this oscillator uses crystal to generate the sine wave, it is known as crystal oscillator. It is just a symbolic name given. Moving to the next block, it is a buffer amplifier. What this stage does is, it isolates the crystal oscillator from the following stages by providing necessary impedance matching. And the next block is the RF voltage amplifier. As the name suggests here, it does the necessary voltage amplification of the signal. Generally, a class A amplifier is used here. And always bear in mind, whenever you have more than one stage of amplification, for example, in this particular block, you can see that there is a voltage amplifier and then there is a power amplifier. In this condition, it is a must that always you first draw the voltage amplifier and then go for power amplifier, because usually the amplification is done as in this particular sequence. First, the voltage and the current amplification part is dealt with, and usually the power amplification is done as the last level of amplification. So here, this particular RF voltage amplifier, as I told you, it is a class A amplifier used to amplify the signals generated by the oscillator. And then there is a second level of amplification, which is using the class C power amplifier. So here what happens is, the power level of the signal is increased such that it is now capable of driving this particular modulator block. So this is about RF section. Moving on to the AF section. Here, the first part, you can see a symbolic representation of a human being who is generating the audio signals. Now these audio signals, they are in the non-electrical form. So the first conversion is done into the electrical form with the help of mic. So what the mic does is it converts the non-electrical audio signals into the proportional electrical signals. Now this signal is fed to the AF processor and filter block. What this particular block will do is it will filter off any of the audio signal frequencies which are greater than 5 kilohertz. So this filter block in particular, it blocks off or it filters off all those audio signals whose frequency is greater than 5 kilohertz. And once the filtering is done, the signal is passed on to the preamplifier. Here this is again a voltage amplifier, and what this does is it amplifies or increases the voltage level of the signal that is given by the mic. After this level of voltage amplification, the last level is nothing but the power amplification level. So here the class B push-pull power amplifier is used, and this is used to increase the power level of the particular audio signal. Now this is given as input to the modulator. I hope you remember the modulator block that you studied in the first video. This block will have two inputs. One is the carrier signal, the other is the message signal. So in this particular block, this crystal oscillator generates high frequency sine wave which acts as the carrier signal, and the strength of the carrier signal is sufficiently increased and fed to the modulator block. Here it is the audio signals, that is nothing but the modulating signal. After undergoing sufficient amount of amplification, it is fed to the modulator block. Now what the modulator block does is it converts these two signals into amplitude modulated signal. And here generally a class C transistor power amplifier that we studied a while ago is used. Once these AM waves are generated, it is transmitted to the open atmosphere through this antenna. The antenna radiates the modulated wave as electromagnetic waves into the open space. So this completes the explanation for AM transmitter. And let me tell you, this is one of the very important block diagram. These are the necessary points for your notes. You can just make a note of this. And with this, students, we come to the end of the amplitude modulation. Shortly, we will be starting with the problems on this particular topic. So before we could start with the problems, I want you all to be ready with all the formulae that we discussed till date. So please make a note of all the formulae in a sheet of paper and keep them ready before we could start on with the problems. With this, we wind up this particular session. Thank you everyone. Have a good day.